here is Richard Moulds, General Manager of Amazon Bracket, part of Amazon Web Services, who's going to tell us about quantum computing in the cloud. And is it really true that there's nothing useful you can do with it today? Let's see.
So yes, I think it is true that there's nothing useful you can do with it today. Here we go. So by way of introduction, so for those of you that don't know, AWS is obviously the cloud business unit of Amazon. It's a large cloud platform, about 180 or so services. Essentially the same sort of business model, pay as you go, common user experience, everything from AI to robotics, IoT, and of course tons and tons of compute. There's about 3 quantum things going on inside AWS. I'll talk about Amazon Bracket, which is my service mostly today. The second area is a consulting group, which we call the Amazon Quantum Solutions Lab. And then the third area is the AWS Center for Quantum Computing, which is located on the Caltech campus in Pasadena, California, where we're building our own quantum computer. Not talking about that today. Hopefully at some point in the future it will show up on the Bracket service and you can all get to play with it. But today we'll just talk about the service and how we think impacts the industry for now. I imagine lots of you came here today to try and answer this question. Tough to follow Scott. I think Scott would clearly position us very much in the discovery phase of this industry, and I certainly do too. We clearly have a long way to go before we get into the production era. It's interesting, I think, that the transition could be quite quick when it happens, not necessarily from a delivery point of view or supply point of view, from a demand point of view. You know, as soon as somebody in some industry, whether it's material science or insurance or banking or pharmaceuticals, demonstrates a proof of quantum advantage, then of course all of their competitors will want to do it literally the next day because it is disruptive technology almost by definition. So demand will happen quickly, and really our job as a cloud service provider is to ensure that we can supply that demand at the right time. So I have no idea where we are between these 2 phases. I don't think anybody else does either. The point is, I think the cloud provides a critical component in the evolution of this industry, you know, in both of these 2 phases. We talk about commercializing quantum computing. You know, today, commercializing quantum computing means making interesting devices available essentially to a research community, to an algorithmic development community, to a lot of educators, and you know, as Michael Cuthbert talked about earlier today, you know, building up that sense of community and that sense of connectedness to try and innovate in this space as quickly as possible. Now, of course, as we go down this journey, we are going to take, no doubt, a bunch of missteps. Our job is to try and avoid them and get past them as quickly as possible. There will be some really bad ideas in quantum computing in terms of how to build these machines or in applications we could apply them to. There'll be some amazing discoveries, but sadly probably won't be commercially viable. Not all things that work well actually have a business case behind them, even though they may deliver great marketing. You know, our job, as I say, is to iterate through this as quickly as possible and stay focused on the customer. So Amazon, we really believe in the notion of an innovation flywheel. We want to move quickly. We want to try and get industries, you know, rolling at pace. It's an urban legend that Amazon retail started on the back of a napkin with a diagram similar to this, not focused on quantum. The whole point is you can innovate on multiple fronts at the same time across essentially every component of an industry. If you can deliver a benefit, you can move the thing forward, you can accelerate, you know, the cycle around this, you know, essentially virtuous loop. We think the same thing applies in quantum. If you can deliver better quality hardware more easily to a larger number of customers through a decent experience, they can innovate more quickly. We can discover new algorithms. We can improve and drive justification for better tooling and deliver a better operational experience. So that's the philosophy. That's how we approach everything. We've seen this work before, you know, in ML, in IoT, in robotics. You know, we fundamentally draw this diagram whenever we start a new service at AWS. The core is to knock down the barriers to entry and to enable as many people to get involved. So when we launched the Bracket service about 2.5 years or so ago, you know, we were trying to solve the problem that customers were crazy frustrated about how hard it was to get their hands on real machines and how hard it was to figure out what was real and what was wishful thinking in the industry. It's an incredibly noisy market, as those of you that have been here all day today will have detected. Most people are pushing one type of technology or another. We heard really early from customers they just wanted to play the field. They wanted to be able to see what was real, they wanted to be able to get their hands on stuff, and they wanted to be able to see all the different alternatives that were out there. There's a variety of different ways you can build a quantum computer, and they all have very different characteristics. So the first real reason why the cloud, I think, can benefit the industry is helping to build that ecosystem, helping to spin up that flywheel. When we launched the service, we launched with 3 quantum machines, one from D-Wave that Scott mentioned earlier, one of the pioneers in the industry, IonQ building ion trap machines, and Rigetti building superconducting machines. About 2 months or so ago, we added a 4th hardware partner, Oxford Quantum Circuits. They're here today. Really excited. That enabled us to position Bracket as for the first time in Europe. It's important. We're not quite, I don't think, into the realms of caring about things like data residency, but as and when we do, obviously having local hardware is important. We've already pre-announced that we'll be adding a device from a company called QEra to the service, which will be a neutral atom-based machine. Quite interesting. We think that those machines can be quite good for simulating quantum systems. You heard some of the use cases earlier today about potential advances in the area of simulating quantum systems, and we think the QEra device will be good for that, so look out for that during the service. And there'll be others. Our general goal is to have 2 or 3 examples at least of each of the main modalities of building a quantum computer. So Bracket's the place to go if you want to play with different types of quantum and see how they mesh and fit different types of applications. Quantum's important, but it's only one part of the flywheel. Algorithm development, as Scott joked, he spends his day trying to discover new quantum algorithms. That's as important as well. So we've been thrilled. One of the best surprises, really, of launching the Bracket service is how many software providers, how many algorithm experts. These are the folks that really are at the cutting edge in terms of understanding the applications, understanding the compute limitations, understanding the trade-offs relative to classical, very close to the customer. So we've been thrilled how many have decided to build a solution on top of the Bracket service and essentially launch their business on top of AWS. Some of them are here today, so please go interact with them. I think this is also a great example of revving up that flywheel through building a community and generating engagement. It was quite the honor last year for 6 months or so to work with BMW on what they call the BMW Quantum Challenge, ran for about 6 months or so. There are about 70 participants, 16, I think, different countries. We worked with them to define 4 use cases that they thought were of most interest to them in this current era. I know lots of people have used the term NISQ today. I won't try and explain it. In fact, I don't think anyone's tried to explain it yet, which must be quite daunting for those of you that know what it is. We don't have time. So they identified 4 use cases, which are along the sort of dimensions that we've heard about over and over today. So material science, optimization, a little bit about machine learning, and 4 winners: QCware, they're here today. 1QBit, Accenture, and Q&Co, now part of Pascal. So Elvira from BMW is speaking later today. So I'd recommend go to her session, and she'll give more details into these different use cases and challenge. And there's even a conference coming up where all of the finalists will get to present their solutions in Munich in I think, June. Okay, second reason why cloud's interesting, I think, is because it helps when we get to the point of needing operationally capable machines, it helps build that into the fabric. So when we launched Bracket, we were very keen to set the same bar for our service that we set for all of the other AWS services. So in terms of reliability, security, uptime, that type of thing. Now, obviously, delivering a super robust, scalable service with today's quantum machines is a challenge. These things, oftentimes only exist for a couple of hours a day. But the classical components of Bracket, the simulators that we run on the Bracket, the tooling that we build around Bracket, we hold ourselves to the same bar as the rest of AWS, because whilst the industry is trying to figure out how to build an interesting machine, we're trying to figure out what it means to run a quantum service. So when that demand shows up, when advantage actually has been proven, we want to make sure that we're in a position to deliver a production service and understand what it means to scale that type of resource. course, today we're talking really very much about research customers, so very different types of workloads. Oftentimes they're characterizing the hardware, they're running benchmark tests, they're really trying to find the edge cases of all these various different types of technology. So different types of use cases that we might run in production. Over time, of course, as these devices become useful, then we'll start to see actual commercial applications, actual production workloads. A couple of times, I think today, folks have mentioned that quantum computing is not just going to replace classical devices. You see stories of quantum laptops and quantum wristwatches and all that sort of stuff. Total nonsense. Quantum really is a coprocessor. It does a few things very well, does a few things very badly. So think of it in the same way you might think of a crypto coprocessor, graphics coprocessor, quantum coprocessor. Scientists hate it when I put this diagram up, but I think about it as a turbocharger for classical computing. It's about doing some of the things that classical computers do badly. Most of the world will stay classical. Classical will be cheaper and more available, more uptime than quantum will be for many, 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 many decades. So think of it as an accelerator. And what's interesting about that is it gives you the opportunity to keep your eye on the goal and keep your eye on which customers are likely to be impacted most by the arrival of quantum computers. The only people that buy turbochargers are the people that drive fast. So the customers that are pushing the limits of classical computing today are likely to be the ones that benefit from quantum computing first. There's not much point really in worrying about quantum computers if there's still plenty of runway left in your applications for using classical computers. So the reason why I think that's interesting, and the third reason why I think, therefore, the clouds are relevant in this industry, is because the people that are pushing the limits of classical compute are in the cloud right now. Okay? They are the ones that are drawn to the cloud because of the elasticity of the classical compute. They're drawn to the cloud because of its ability to orchestrate huge amounts of compute resources. In AWS, we add the effective capacity of a supercomputer every 3 or 4 days to the service platform. So the people that will benefit from this stuff are in the cloud. We can see what they do. We work with them every day. They are pushing us to deliver new instance types, deliver more regions all the time. So we think we're in the right place to spot those folks and to introduce quantum to them at the right time and find a way to make quantum relevant to them. They're not going to come to the quantum industry. We have to take these interesting coprocessors and make them part of their world, make it part of their tooling, make it part of their experience. This is just an example. Don't try and read the words. It's not quite good enough resolution anyway. It's what's called a directed acyclic graph, or a DAG. It's the way you draw HPC workloads, high-performance compute workloads. This is just the top corner of a complex diagram around gene sequencing. So today, this is all classical, nothing to do with quantum at all. And each one of these nodes is potentially hundreds or thousands of instances running parallel tasks. So these are weighted nodes, each one of them, sometimes a single container, sometimes hundreds of containers. This is what people build and deploy in the cloud today, every day. The companies that we heard from this morning, this is what they do. And this represents, therefore, the world that quantum will need to be part of. Quantum computers will be some of these nodes, maybe only 1 or 2 of these nodes. So how would they build it? AWS, is a portfolio of services. This is just a simple diagram. I'm leaving out all the important stuff like monitoring and reporting and analytics and security and all that stuff. But think of it in terms of 3 layers: a control layer at the top, an orchestration layer in the middle, and a variety of compute services at the bottom: classical compute on the left and quantum compute on the right. So today, Amazon Braket is orchestrating workloads between quantum computers, quantum simulators, and classical compute. Again, won't bore you with what NISC is, but NISC involves an iterative back and forth between classical and quantum compute. That requires some orchestration. That's what Braket does today. We launched a new feature at the end of last year called Hybrid Jobs to do just that. But in the end, you can see how Braket becomes part of the broader HPC orchestration. Products like AWS Batch, Parallel Cluster are our existing tools for orchestrating HPC across the cloud, hundreds of thousands of instances. So we think in the future, this sort of model emerges. We're not really quite there yet, obviously. So first reason why I think cloud is interesting, build an ecosystem, get a community going, get everybody educated, build the workforce that we heard about a lot today. Second reason, is its way of delivering the operational excellence around security, billing, commercial model, etc. And the third is that it's the environment where all this stuff happens today anyway, and the customers that will use cloud computing, or quantum computing rather, already live. You want to get more engaged with us, obviously it's a cloud platform, so anybody can use it. Anybody who wants to play with quantum computers can do so whenever they like. If you're a solution provider, then we have a great partner network, very well developed, tens of thousands of partners with AWS building their business on AWS. We have a partner team dedicated for quantum partners. If you're a researcher or an educator, we have a very well-established credits for research program with AWS. You can apply. I'll give you the link in a minute for you to apply. Not just AWS credits, but Bracket credits as well. If you're an enterprise, then come talk to the Quantum Solutions Lab. It's a long, deep engagement, not tied to specific statements of work, collaborative process. And if you're a hardware provider, there's some in this room, and you want to be on Bracket, we can help save the heavy lifting of building, large public web services and allow you to focus on what you do best, which is building, amazing machines. Here's some links. If you want to get your cameras out, please join Bracket. It's a link at the top of the screen. There's a link to our Solutions Lab. A year or so ago, we started a quantum blog channel. We post a couple of blogs a week. I would recommend you check it out. It's got a lot of interesting stuff. Both our hardware partners and our software partners co-author blogs, as well as some of our customers. If you're interested in research credits, there's a link for it. And if you want to come work for us, I think last time I checked, we have something like 80 open positions right now in quantum in almost every discipline. There's a page dedicated to explain those positions. Anyway, thank you for your time. It's a great pleasure. Nice to be back in London. First time in 3 years. Thanks.